In this video, I will be demonstrating how to import an existing slope stability file into TSLOPE. First, go to File, Import, and you will see a few options available. For this example, I will be importing a Slide 2 file. So I select this option and navigate to the Slide 2 file I want to import into TSLOPE. As you can see, all the materials with all the properties and failure types have been imported into the file, along with a top surface, which has been extruded from 2D into 3D to see T-slope and how it operates, a basal surface, and a phreatic surface. This block search layer becomes relevant later on, and I'll discuss it when we're doing our analysis. The volumes are used to define the boundaries between the different material types, and these again have been extruded from the 2D definition set in the Slide 2 file into 3D. The cross-section is where the existing Slide 2 file would have focused on, and if we open the slope in 2D, we can check the different surfaces and the settings for the slope, as well as changing the limits of the slope to adjust where we think the failure might happen. In the defined basal failure surface, you will see that block search layer, as mentioned before, is in this, and this is to clip the failure surface to this layer and make it known that this is a weak layer and the failure surface should not extend below this. And you might want to do this if you know that the failure surface is always going to be across this particular weak layer or weak plane, to force the software to not extend it under this layer. So once we've checked that all the properties are as we want them to be, we can press solve, and the software will run through all the different failure options and provide the failure surface that makes the minimum factor of safety value. So here the factor of safety has been determined to be 1.04, and you can compare this to the factor of safety you acquired from the Slide 2 project and compare the results. The other additional benefit TSLOPE has is that we can compare this directly to the 3D slope situation. So as you can see, I duplicated the surface so that we have a copy of that basal plane that was calculated from the 2D scenario. And now I'm going to set up my 3D slope, and I can check all the properties like I did before. It's got the phreatic surface and the top surface, as well as all the material properties as defined previously. So there's not really much that you then need to change. Maybe adjust things in the analysis, but really you could just press solve on this and get a whole different factor of safety. So this factor of safety is 1.77 for the 3D scenario, which is a lot higher than the 1.04 factor of safety calculated for the 2D scenario. This is because the 3D assessment involves a higher proportion of columns within the higher strength materials above the weak layer, which results in the 2D scenario providing an overly conservative factor of safety. TSLOPE allows you to run both 2D and 3D scenarios in the same software to compare the results. Thanks for watching the video. If you have any questions, please reach out at support@targasoft.com. Check out the other help documentation to get started with your TSLOPE project.